Hey guys, second to last coding video for this intro course. So welcome to Python Computational Biology. We're finishing up, so we're going to do translation now. So the last time we did transcription, now we're taking the RNA, we're going to translate it into an amino acid sequence that gets folded into a protein, right? So very similar strategy, I guess. So let me pull up, where's my notepad. So we're going to do the same thing. Oh my gosh, notepad, there we go. So we're going to do a very similar thing to our last one. So we're going to kind of come up with our strategy here. I wish I could. Oh, zoom, I can zoom. Oh, sorry for the last one. I'm not a super notepad user. I didn't realize I could zoom my in. It's like going up like one font size at a time. Okay, so first, prompt the user to enter the name of a file that has an RNA sequence. So that's very similar to our previous one, our DNA sequence, or our transcription. Then we want to open the file the user indicated. Easy enough. So 3, we want to translate the RNA codons. Remember, so for translation, 3 nucleotides are read at a time. That's called a codon. Those 3 are then transcribed into an associated amino acid, which is incorporated into the amino acid chain. So we're going to translate the RNA codons into an amino acid using a codon table that we're going to build. And then prompt the user to save the file as a protein sequence, print the amino acid sequence. So once again, forward 5, you can switch. So as you can see, this is very similar to the transcription one. It's just a little more difficult because we have to read codons and we have to do that's really it. That's the difficult part, is it's codons and an amino acid table. So it's just multiples harder. So if you've forgotten an amino acid, the amino acids, as you can see, we have our 4 nucleotides. Can I make this bigger? A little bit. Zoom. Enhance. There we go. All right. So as you can see, we have our 4 nucleotides, right? So this would be T for DNA, but it's U because it's RNA. So UCAG, and then UC, and then behind my picture is AG. And then for each triplicate, this is a reminder for genetics, or I think you probably learned this in biochemistry. I can't remember, it's been years. But for genetics, each 3 of these corresponds to an associated amino acid. And there is duplicates. So usually the 3rd position is called a wobble base. So as you can see, UC and then any of the other 4, it doesn't matter what the 3rd position wobble base is. That 3rd position, as long as you have a U and a C together, it's going to make a serine, right? And the same thing with for proline. So CC, regardless of whatever the 4th position is, makes proline. AC, no, that's a bad example because CU makes leucine, regardless of UCA or G at the wobble base, the 3rd position. So we're going to have it read 3 at a time and then use this table to look up what amino acid should be added to the growing chain. So it's a little bit more difficult. It's like 1 step more difficult. So let's go ahead and start. So I'm going to save notebook as, I'm going to call this translation. So we have transcription, then translation, the central dogma of genetics. So first things first, let's annotate. Prompts the user to enter the input RNA file name. So this should be the file that you saved in the last one. Whatever you entered as the output file, it's the input file here. So input file name equals input. And we're going to say enter the name of the input RNA file that, that you saved in the last one. So run it. And what did we save it as? I saved it as ubiquitin because I gave up on sumo because it was weird. Ubiquitin RNA.txt. Enter. Wonderful. Okay, so now we're going to open the input RNA file and read the RNA sequence. All right, so we'll say with open input file name R as input file. Oh, I feel a sneeze coming out. Oh, that impending sneeze. All right. With open input file name R as input file, RNA sequence equals input file, underscore file, read, oh my gosh, strip. Okay, so this is going to read it and then strip off each independent nucleotide. All right, I'm going to cheat. Instead of you watching me type this whole codon table, I am going to cut and paste, but you are going to have to type, unfortunately. Unless you can find this code online somewhere, maybe you can. But if you watched me, like, it would be like pulling teeth if you had to watch me type this because you see my typos. Yeah, you don't want to watch that. So this is a complete codon table. Go up and bracket. Okay. So you can see all the U's here, make the different amino acids, etc. So I'm going to maybe. Why isn't my Zoom working on? Okay. Here, I probably should have to zoom to this much anyway. Here is the codon table, so you can like pause it or take a screenshot, and then be good to type it up. All right, so I'm gonna run this codon table. Okay. Now I'm going to translate RNA to protein. So protein sequence. See, that's why I don't zoom, because it's not capturing everything. Okay. Let's zoom back out a little bit so it captures my whole screen. Okay. Protein sequence equals. And we're just going to do empty brackets again. So we're saying just create an empty thing because we're going to add one at a time. And we're going to say for I in range 0, then RNA sequence 3. So we're saying read for I in range of 0 through the length of RNA sequence to break it into 3s, because we want codons, right? We want those 3 letters so we can translate 3 letters at a time. We're going to say codon equals 3. Oh, no. I'm skipping ahead here. Equals RNA sequence I plus 3. So this is breaking it apart into 3s if the length of codon equals 3, which it should because we're breaking it into groups of 3. amino acid equals codon table, and then look up whatever the codon is. Codon. So it says go and look this codon, which is 3 amino acids or nucleic acids, and then find the matching letter from the codon table. If amino acid equals star, break. So we're saying if it's anything but else, stop. Protein sequence equals amino acid. Okay. So this is RNA. How do I spell sequence right? Why did I spell it wrong? For I. For I in range 0, length of RNA sequence 3, codon equals RNA sequence I plus 3, if length of codon equals 3, amino acid equals codon table codon, string index out of range 5, codon RNA sequence I through I plus 3. I did I plus I. So I colon I plus 3. Oh, okay. Break. Not Brack. Brack. You guys will not get this reference, but there was a character on the show called Space Ghost Coast to Coast when I was in high school called Brack. It's trivia. You'll just let it go right through your one ear out the other. It doesn't make any sense for me to bring that up. Just reminiscing. All right. So let's go on to the next one. Prompts the user to enter the output file name. This is similar to the last one. So say output file name equals input. Enter the name of the output file, just like last time, and we're going to say ubiquitin protein.txt. And then we're going to say save the protein sequence to a text file. And we're say with open output file name w as output file output file dot write protein sequence print the protein sequence has been saved to, and I don't think it's going to work again, but we're going to try it. Output file name. Assuming it's just going to save the same thing, and I don't know why that is, but let's try it. Hey, it worked this time. I don't know why it didn't work last time. I'm like surprising myself. I must have had a typo or something in the last one. But yeah, so now it prints it's been saved to protein.txt, which is great because that's what we saved it to. Awesome. All right, and then last thing, we have to print protein sequence just to see what it is for our own knowledge. And here you go. There's the amino acid sequence of ubiquitin, or your protein of choice. If you had sumo work, if you picked BRCA1 or BRCA2, some cancer genes, breast cancer genes. If you picked whatever, heat shock proteins, our favorite I like to bring up. What is mod 1. Is that the one that Dr. Newman works on? Can't remember. Mediator, no, med 1, med 2, your med whatever number. Yeah, that's it. So as you can see, this one's a little more complicated because we had to incorporate some like loops or some if-then statements to break it into codons, and we had a huge codon table that we had to incorporate instead of just changing T's to U's and then keeping the regular other nucleotides. But it works. It's cool. It's only 10 chunks of code, not very much. So I hope you enjoyed the video. I hope you learned a little something a little more complicated. You can continue to ratchet up the complication for these things. We got one more. We're going to do some of the COVID stuff, but I don't think I have much else to say. I hope you enjoyed the video. Hit like, hit subscribe, and I'll catch you in the next video.